record. Okay, guys, we're gonna bounce around on a few things. One of the things I want to talk about Frigidaire is a little bit about their controls, a little bit about their dispenser system, something that a lot of people have problems understanding how this works, as well as ice makers. And we're gonna go over two different types of ice makers today. And then next week, we're gonna go over actually like the Whirlpool 50-pound ice machines. They're the small under-counter ice makers that are in customers' homes. Here we got two Frigidaire diagrams, and this one has a mechanical timer for defrost. This has an electronic refrigerator for defrost. I'm not going to go over the schematic itself right now. What I want to do is, let's see if I can expand this. Oops, I have to do it this way. Is I want to talk about this dispenser circuit. Let me zoom in and then I can get the small part of it to show. And that's this right here. Do you guys see those components right there? What do they look like?
Resistors?
Not resistor.
They look like windings.
Windings? Yeah, they're windings. Let me see if I can zoom in a little more. For some reason, the diagram won't let me expand it. I can. Give me a second. Here. The problem is it's off the screen. There we go. Now I can expand. Okay, what do you think there are now?
Well, solenoids.
They're solenoids. Why 3 solenoids? Does anybody know what the 3 solenoids are? Yeah, go ahead.
One for the arm, one for
For the arm?
for the ice maker, right?
Okay, one for the ice maker.
Yeah. Oh, then for the entire unit, those are the 3
Well,
solenoids?
we have 3 solenoids. Why do we have 3 solenoids? This is for the whole refrigerator.
Okay, so there's at least 2 of them for the water valves then, I'm guessing, and then one for the ice maker itself?
What do you mean 2 for the water valve?
Well, because there's a water valve on the ice maker and then there's one at the bottom too, isn't there?
No, they're all in the bottom.
They're all on the bottom.
This ice maker here, when it is running, it sends power down to the water valve. That water valve is the same as the water valve on the door of the fridge. But why 3 solenoids? If one's for the ice maker, what do the others do?
I think one control the bottom.
Oh, I know exactly what it is. Oh, I'm so sorry.
Right.
The main water valve would be the water line that's connected from the actual like house to the refrigerator, and then the dispenser water valve would be for the water dispenser.
Yeah, but if we looked at the water valve, and let me just do a quick Google search here. My mouse working? There it is.
That's what I think.
Okay, here we go. Here's a refrigerator water valve. This one actually has 4. I was hoping to find one with 3 solenoids. Let me double check real quick. Here, this one has 3 solenoids. We have 1 solenoid here and 2 solenoids there. It's all a single assembly. It gets replaced together complete as one piece. But why 3 solenoids?
One allows for the main water line coming into the fridge. One is for the dispenser valve itself on the switch on the door, and the other for the ice maker itself.
Okay, but we only really need 2. One to go to the ice maker and one to go to the door. So why the third one?
The third one is as a protectant, so the system doesn't constantly if one of the others fail.
No.
Is it like a filter?
It's a filter? No.
No.
I think one goes to the water filter. So, filter for the water. Goes to the ice maker.
Oh, I see.
You're close, but that's not why. Yes.
The third one is for the water line.
But we said that it's on the water line, and then you got one for the ice maker, and you got one for the water in the door. But really, let me close this one here. This one's in the way. Really, this unit here, and I'm just going to draw a quick thing is you have the water line, here's the house, here's your refrigerator. Okay? And you have this solenoid, 1, 2, 3. The water comes into the first solenoid here. This one runs all the way up to the filter inside the refrigerator. And a lot of manufacturers do this. Some of them use 4 valves, but I want to show you what Frigidaire does in this schematic and why it's important, because sometimes something goes wrong with that and different things happen screwy with that. So they have the first water valve, and I'm just going to number it number 1 here. That water valve goes up into the filter inside the refrigerator. From that filter, the water line comes back this way and goes back down to the valve here where we have the 2 solenoids. And I'm going to number them 2 and 3. And then from here, number 3 goes up to the ice maker, which makes ice. And number 2 goes into the refrigerator where there's either a tank or a plastic nylon hose that's coiled up all the way in the bottom of the refrigerator section. It's usually behind the vegetable bins and the crisper bins. And that's where the water gets cold for a customer when they get water on the door. The problem with that is the misconception is that when they put that water on the door there, this water here goes up to the ice maker, down into this tank, and then this tank runs down under the fridge and then comes up through the door to the dispenser. Down here you got your compressor and your condenser.
Except the water.
So this water is being chilled and is going to get as cold as your refrigerator. It only holds about 1 or 2 big cups of water. Okay? They're not a lot of water. So if there's 4 people in your house, this thing's going to empty out and fill up with just tap water. It's not going to be cold. That's why they have an ice maker next to it. But the other thing is this line through the door and on the bottom is getting the heat of the compressor. So that water's a little bit warm when you first put your cup before this water inside the fridge comes up behind it and comes out into your glass. Okay? A lot of people expect it to be as cold as those water fountains. You know, when you walk in a mall or something, you drink out of a fountain that's got a little compressor refrigerated unit. That's cold water. This is called chilled water, and it's not going to be exactly the temperature of the fridge. Okay? Now, why 3 solenoids? Can't they just put 2, 1 for the ice maker and 1 for the water on the door? Yes, that's how refrigerators were done 30 years ago. Why? Because customers, if they wanted a filter, the filter for the water was here between the wall and the fridge. If the customer's filter went bad, either the customer never replaced it because they had to pull the fridge out and they forgot it was back there, or in order to replace it, you have to pull the fridge out, you have to shut the water supply off here, reconnect it. Moving the refrigerator, it's copper lines, it causes leaking. Sometimes the valve, when you turn it off and on, starts to leak and goes bad. Manufacturer said, hey, let's put the filter inside the fridge. Customer can easily twist it out, pop a new one in. We could sell more filters, but we got a problem. Just like this one, I have to turn off the water to change it. But if I put this solenoid valve right here in the front, I can unscrew the filter, pop a new one in. I never have to turn the water off because valve number 1 is stopping the water pressure from the house as you're changing the filter. Yes?
So say, for example, most Frigidaire refrigerators that have that sort of setup, the water would not run, the water dispenser would not run if the filter is not there?
In some units, you take the filter out and you call for water, the ice maker calls for water, it'll leak. Some design, like Whirlpool, they have them down on the bottom at the grill, and when you twist the filter to take it out, where the inlet and the outlet of the water, the plastic piece twists and creates what we call a bypass. And it bypasses that filter assembly, so when the filter's out, if by any chance someone calls for water, or the ice maker calls for water at that point, no water will leak out. It'll just bypass, not be filtered, it'll come straight up. Okay? But I've seen where some people have taken it out, while they took it out, before they got a chance to put the new one in, the ice maker called for water, and water went all over the top shelf of their fridge. It doesn't happen very often.
No, of course.
So a lot of manufacturers, what they did to alleviate when the dispenser or the filter's out, is one of the things they did is they did not allow the ice maker to run when the door switch was open. That way, if they got the door open or changing the filter, even if the ice maker was in the middle of the cycle and you open that door, the ice maker will stop right there and will not move till the customer closes the door. Now, if they take the filter out, close the door, and come back 20 minutes later, they got a mess. Okay? But they tried at least by putting the ice maker in series with the door switch to see if that will eliminate it. And if we look here, and let me move this here, is this ice maker in series with any type of door switch? No. So this particular model doesn't have that. All right? But there's something you need to pay attention to. Because this here is where the customer puts the glass calling for water. It's basically just a micro switch. When you press down, a switch closes, sends power. Well, we got 3 solenoids, so whether it's the ice maker or the water on the door being energized, we have to turn on valve number 1, right? Because if we don't turn on valve number 1, water won't go through the filter and won't come back here. It won't go to the other 2. So we always have to turn on number 1, but we may turn on 1 and 2 or 1 and 3. And that's like this diagram here. If I want water through the door, I want the main water valve, number 1, to be energized, but I want the dispenser water valve to shoot the water out the door. If the ice maker comes on, I want water valve number 1 here, but I want the ice maker water valve so it sends the water to the ice maker. But if I send power from here to this solenoid, and I go up here to this solenoid, what problem can I create by doing that?
Can you say it again? A question.
If I send power to these 2 solenoids, what problem can happen by the way everything's wired?
I think when you press the main line,
Could the power go this way to the other solenoid? Yeah. So Frigidaire had to figure out a way, okay, if we're gonna put 3 solenoids, and whether the ice maker wants these 2, or the water in the door wants these 2, we always have to energize this one. How do we stop that 3rd valve from coming on?
With a diode.
With a diode. So if we look closely, Chris, you were close, it was not a fuse, that's actually 2 diodes. It's a little hard to see, but if I could expand the diagram a little bit more. Okay, let me get my mouse, because this software won't let me get too big here. I can make it bigger for you to see it. Let's see. A little hard to see, but can you see the 2 arrows pointing this way? You can't see the little arrow right there. Get closer, Julian, you're blind. But there's an arrow like this
I see it.
and another arrow like this.
Yeah,
There's
I
2 of them.
I see it.
Okay? Remember, in the diode, the arrow points towards the wall. That means electricity cannot go that direction. So if you have a diode that looks like this, okay, electricity will flow this way. It will not flow that way. So if you look at both those arrows, they're both pointing towards me. So when power comes on, it'll go this way, and it'll go this way. It cannot go back to the other solenoid. And then the same thing happens because there's 2 diodes. Oh, I hit that by mistake. Just close that. Because there's 2 diodes, the voltage will go this way and the voltage will go this way. It cannot go back. Now, first of all, like when you guys tested microwave diodes, the resistance was very high. So a diode is similar to a resistor. You do get a drop in voltage to this water valve solenoid. You will not have 120 volts at that solenoid. Sometimes it'd be 80 or 90 volts, maybe a little less, because it has to go through the diode. So you're going to get a voltage drop, but that solenoid is designed to run at that lower voltage. You need to know that. But what happens if one of those diodes shorts out? First of all, what does it mean when I say a diode is shorted?
That means that it would let voltage go across both sides.
It'll let voltage go both ways. So if this bottom diode right here was shorted, give me a hypothetical problem that would happen with a shorted diode. If the bottom diode was shorted.
Well, if the ice maker is calling on the water valves to activate, it also dispenses water out of the dispenser.
So a customer would wake up in the morning and there was water all over the floor. And what happened is the ice maker called for water. And because the bottom diode shorted, the power was able to come back around and turn on that one. But if the bottom one shorted, the water would dispense normally and nothing would happen to the ice maker. But if the top one was shorted, every time you called for water would be going into that ice maker and you'd be making a mess in the fridge. Yes?
I have seen something like that happen.
On a
the other
Frigidaire?
day. Actually, it was on an LG refrigerator. Every time I would call for water on the dispenser, you would hear this. It would start filling up the ice maker to the point where it was just overflowing.
Now I don't know if I
yeah.
don't have a diagram, so I don't know if they use diodes like Frigidaire.
Oh,
But-
it could be that the wires are.
But these diodes are not like in a microwave, you see a diode sitting right on the capacitor. These diodes are part of the wiring harness on the bottom of the fridge. And you have to actually replace the wiring harness with the diodes. And they can be tested out with an ohm meter. You can check continuity one way and the other way infinity. Yes, sir.
Now, so if the bottom one shorted out, every time the ice maker harvested, like every 2 or 3 hours, it would just spray more water.
And it would be running on the customer's floor.
Okay.
Now, this doesn't happen a lot. It's not, I change one every other day or I'd probably change 2 in my lifetime. But I didn't know the diodes existed, but then it dawned on me, like, how do you control 3? How do you get power to that one and not turn on that third one? And they do it using diodes. And this is in the electronic machine, the mechanical machine. So you need to know that this is diodes, and it's part of the wiring harness. It's not part of the water valve. The manufacturer, instead of putting it in the harness, could have put it right on the valve. So if the diode was bad, you just changed the valve, and the diode was internal in the valve, or mounted on top of the valve where the plug went. It really not that expensive to make a valve.
No.
They may sell them for $40 or $60. It costs them $5 to make.
Yeah, but that's the whole point. They make more money by making you replace the board every time.
No, not the board, the wiring harness.
Or the wiring harness.
You'd have to actually replace all the wiring on the bottom. Even the wiring to the compressor is part of that harness. You have to replace it all. Okay? And I tell you what, technician, rather change a water valve than be fishing wires from the back of the fridge to the front of the fridge, because those wires run everywhere inside the machine. Okay, they're on the side by side. Could be anything that has a dispenser on the door, and it's got 3 solenoids on Frigidaire. It has those diodes in them, so you have to be aware of those diodes. Okay. Now, if you look at this ice maker, we got 1, 2, 3 main wires. We got line 1 coming in. We got neutral coming out, and this one here is power to the water valve from the ice maker, which is line 1 coming in and down. Okay, that's the main thing of most ice makers. We got to send power to the motor, the heating element, and everything else inside the ice maker. And when it wants water, it sends the voltage down. Now, the ice maker's in the freezer. The water valve's in the bottom and the back of the fridge. So that ice maker's sending power all the way down there to tell the water to come up. Okay. One little tricks I learned is, let's say you go to someone's house, look at the ice maker, and they say, no ice. So you look here, and you don't see any water in the ice maker. If you don't see any water in the ice maker, and the customer says there's no ice, the ice bucket is empty, you could have a bad ice maker, but more likely you might have a bad water valve not sending water up. So you have to say, okay, how do I know which one's which? I'm going to show you some ways to test this ice maker out and another one, but instead of sending, you know, power down to it or whatever, I would go back to the refrigerator and I'd unplug the two wires from here. Because remember, I showed you the picture, the valves are all together. And I'd take these two wires off and put them on this one here. So I want to know if water's coming through. If I can get water to come through, I know the water valve's good and I know my problem's in the ice maker. So if I take this plug off of here and put this plug on here, how do I test it?
You going ahead and use the dispenser for the water to fill up the ice maker.
So if you switch the ice maker water valve and the water on the door, take the ice maker water valve wires off and take the one off the solenoid going to the door and put there, the power going there. When you just push on the lever on the door, it'll send water up into the ice maker.
But don't you have to, like, how many seconds do you have to count before you realize that you overfill the ice maker?
Does it, you know, like
I know.
3 seconds, 5 seconds.
Okay, I'm only kidding there, but alright.
You can also see the edge of the board.
All right?
That's pretty
So it's just a quick way to send power to the water valve and to make sure you get water up there. If you get water up there, you know, I'm not messing with the water valve, my problem's at my ice maker. Right? Quick test. Okay.
It uses the same plug.
That is good.
Now, let's talk about ice makers. I got a couple of ice makers here and I want to talk to you about the ice makers themselves. Yes, sir.
Yeah, before that. Sometimes the complaint is no ice, no water. That's probably the main part we talk about, no power thing.
No ice and no water. Could you still switch them and see if water's coming into your ice maker? If someone calls you out and says there's no ice, and we're going to talk about ice makers now. Someone calls you out and says there's no ice. What do you do before you start taking anything apart?
Do whatever?
What do you do? You what? You check
Check the shut off.
check the shutoff valve?
Yeah.
Yeah, see if there's water
Yeah,
coming
yeah.
in, right? So now the water's turned down. What are you going to do?
I mean,
Yeah.
what I usually do.
Wait, he raised his hand.
She said there's no ice or water.
Neither.
Neither. I'll check my notes. I'll check to see
Oh.
if they're being honest with the complaint, because there could be ice and water in there. But I'll check the inlets.
Okay, but I mean, go ahead, Julia. Hold on.
Oh no, I mean that's usually it. I mean first I'll check the water line. I mean then I'll go ahead and check the dispenser and then check to see if there's any water in the ice maker, or if
Yeah.
there's any frozen ice cubes in the ice maker. See if there's any sort of residue.
Okay. Is it possible you have two problems, one for the ice maker, one for the water?
There's
Yeah, and for the ice, or sometimes we're not able to check the filter. If the filter is clogged, is frozen,
Okay.
we're not gonna get ice.
Or water to the ice maker, yes.
First, I'll check your temperature. to make
Check
sure.
temperature. But how would temperature affect the water on the door?
Because
It's too cold.
it has to be cold enough for the thermostat to close to send power to the water.
No, but you put your cup in the door and you want water, no water's coming out. How
Well, the-
is the temperature of the refrigerator going to affect that? Even if the refrigerator's warm, you could put your cup there and water should come out.
Yeah, but if the line, let's say that the refrigerator is getting too cold and it's freezing up, like I've had juice in the back of mine before where it freezes up, that line is still stored in the inside of it, right? So couldn't the water freeze up in that coiled up line that's holding two or
Well,
three
right
cups of
now,
water?
Frigidaire has a side-by-side refrigerator model. They have a repair kit. Because all refrigerators, there are exclusions, one with dual evaporators, but most refrigerators, side-by-side and top and bottom, let's stay with the side-by-side right now. The evaporator, which cools the fridge, is in the freezer. And there's a fan that circulates air into the fridge, and then there's a hole that returns the air. So the freezer is cooling the fridge. But the filter's up top here where I had that drawing, and the air's coming out of the freezer here. What's happening?
Damper, the damper.
Well, not just the damper, but I'm blowing the cold air right onto the freezer. And so what happens to the water inside the filter?
It freezes.
It freezes that filter.
Yeah,
So now they have like a little plastic kit, like a deflector, that deflects the way air flows so it doesn't hit that filter.
every day I'm dealing with that thing.
That happens a
Every
lot.
single day.
You gotta tell customers turn the fridge down.
Every single day I'm dealing with that.
GE side-by-side refrigerators, a lot of the older models, okay? There's a water line that runs through the door and comes to where you put your cup.
Exactly.
Those doors, the insulation inside is liquid foam. It's not fiberglass like
Yeah,
the real ones,
Yeah, it's for, yeah.
okay? And if they get so cold that the water in that little hose to the door freezes solid.
Yeah.
Now, you got two options. Tell the customer, unplug the fridge and let that defrost, about an hour or so. You put all your food in the freezer and everything else till it melts. Your watering door is going to work. Well, what's going to happen?
It's gonna happen again.
It's going to freeze again. So the only fix is, normally would be just replace the water line. Now you can't get it out because they use liquid foam and they don't run an individual channel that the hose can go in and out of. So you have to change the whole entire freezer door. I had guys who were changing freezer doors and then 5-6 months later, guess what?
It happened again.
Freezing up again. If the design is the hose is too close to the liner inside the door and not insulated well enough so that the freezer's so cold it's freezing that water line. You gotta raise the freezer temperature, make it warmer so that line don't freeze. That's the only thing you can do. Way you check it is right where the hose goes in the bottom of the door. It's right where the hinge is. The hose goes up inside the door. You just disconnect it, you put your cup there, water starts shooting out, but it's not coming through the door, you know it's frozen. That's it.
Yeah.
That's it. Yes.
How big is that hole?
The hose?
The hole. Where the hose
The
goes
hole
into.
for the hinge or the hole for the hose?
For the hose.
Inside the hose, the hole is, I don't know, about 1/8 of an inch in diameter. I don't know the actual dimensions.
No, I'm just
It's
thinking
not,
roughly.
it's not big. Hold on, I'll get you
But
something.
sometimes, you know.
You want me to stop this then?
2 days ago,
Pause it.
was,
He said to keep
was,
going.
was 2 days ago, I got a tennis complaint for the no water in the dispenser.
Yeah.
When I check everything, just the little thing, the water line is, you know, it twists.
Okay, so this is the nylon hose.
Yeah, I think
Now,
that's the same thing.
when you look in the back of a refrigerator, you'll see some hoses a little bit bigger than the others. The bigger hoses are the ones that are coming to the water on the door because you want to fill a glass,
More rapidly.
fast. Ice makers only fill about 3 or 4 ounces of water. It's very little. So the diameter of the hose is not that big to reduce the pressure and how fast it comes in. Because it comes in too fast into an ice maker, it can splash everywhere. So they want to slow it down a little bit and send power to the valve a specific amount of time to fill up the ice maker. And ice makers are time filled. Okay? They don't have like a water level switch that says, okay, I'm full, turn off the water valve.
No.
So the inside this diameter of this hose is very small. Okay?
Sometimes they twist.
Well, the reason I asked is I was thinking, would there be a way to like, I don't know, like electrical conduit or something like that?
To
Maybe.
fish another hose through it?
Well, not necessarily fish under the hose, but at least fish up to where you could make that line a little bit out of the foam, where you can make it move out a
You
little bit
can't
with the
move it
wall.
because the
Or
whole
to shield it.
entire of the door is like the new coolers where they just fill it with liquid foam and that hose is there. You can't move it. It's solidified.
Yeah.
And when they put that liquid foam, the old door panels, the plastic liners, had screws all around where the gasket where you could take the screws and take the door apart and service it. You could change the insulation if it was wet. These here are liquid foamed. There's no screws holding the two together. They sandwich it together, they inject the mold, and that's it. It don't come apart unless you're ripping it apart.